laps, you do have 5 miles remaining. After you run 4 laps, you do have 4 miles remaining. Over here, it says that after you've run 0 laps, you've had 0 miles remaining. Well, if we change this word to miles completed, that would work. All right, but that's not what the question says. So miles completed, yeah, after 4 laps, you do have 1 mile completed, but not remaining. So you're counting down from 5 miles, and that's why G is the best choice. All right. So, moving on, we're now going to deal with 2 equations at the same time. System of equations. So, Sam needs to rent a van for a school field trip. Van company A charges a one-time fee of $250 plus $10 for each. That's that per, for each, every, okay? So for each mile, I'll take the M off of mile and put it next to 10. Perfect. There's van company A. Here's van company B. Charges a one-time fee of $150 plus $12 for each mile driven. All right, so there's our 2 equations. If we just map it out like we said, circle our numbers, plus 12, notice the for each, every, per, and whatever letter leads off the next one that tells you what the units are, that's the letter you're going to use. So if I'm looking at this in here, I know that I need my variables on the 10 and the 12. So automatically that takes out C. All right, I know everything's positive, which takes out A and B. And I know that D is my right answer. Remember with addition, I can flip these around and they're the same thing. 10M plus 250, 12M plus 150. Now, in systems of equations, sometimes you'll be asked to solve things. All right? With a system, notice, van company A charges more money on the outset, but it's less money per mile. All right? Van company B charges less money on the outset, but it's more per mile. So, van company B will start out less expensive, but over time it will get more expensive. But we got to find out where. All right? Van company A starts out more expensive. You might be scared off by it. But if you knew you were going to drive a lot of miles, specifically, the amount of miles past where these 2 costs are equal, van company A is actually going to be your best choice. We can do this graphically, and we can also do this algebraically. I have the screenshots to show you graphically. Y equals, we're going to put both equations of y1 and y2. All right? Remember, there's a variable key. It's up by alpha, if you look at a calculator, that can give you x. All right? So from there, I want to go second window. That's going to take you to your table setup. Make sure you start your table at 0 and you change your table by 1. All right? Then second graph takes you to your table. All you want to do is scroll down until you find y1 equal to y2. And that's going to be the number of miles that you can drive for either van company and have it cost the same amount of money. So I scroll down here and I notice it's getting closer and closer. Right here. At 50 miles, it's $750 for both van companies. Nifty. I didn't have to do any math. All I did was came up with the equations. So at 50 miles, both of these van companies are going to charge the same amount of money. So again, if I'm going to drive anything less than 50 miles, I'm going to go with van company B, because they don't charge as much up front. If I'm going to go anything more than 50 miles, I'm going to go with van company A, because their per mile cost is less. We can do this algebraically, and I'm going to show you kind of a quick way to do it. If you notice that the difference between our one-time fees is $100, and the difference between our cost per mile is $2, all right? We've done all the subtraction we need to do. I know that this 10 is on top of the 12, which should mean it's a negative number, but I'm just looking for the whole difference, or the absolute difference between 10 and 12, all right? Which is $2 per mile, all right? So that's how much more van company B charges than A. When I get these 2 differences, the difference in their y-intercepts, or one-time fees, and the difference in their slopes, or their cost per mile, I can just divide. And I find that M is equal to 50. Not too bad, all right? So depending on what you're fast with, calculator or algebra, you can find the same result. All right. Last thing, graphs. We need to be able to read some graphs, especially curves. Everyone freaks out when we have curves. It's just a curve. It's on the same coordinate system you find a straight line. All right? So, curves do not freak us out. So, question is, it shows the population growth for the United States since the year 1800. According to the curve of best fit, in what year will the population be 300 million? Well, I know that it shows years and it shows population. So I want to find out where the population is 300 million. All right? And I'm looking for what year. So I'm going to follow it over until it hits the curve. And I'm going to follow it back down. And I find that it's really close to right between 2000 and then the year 2050. So halfway between that is 2025. And I find that in my answers, I have actually 2024. Because if you were to look at this really close, you'd see that this doesn't quite hit 2025. So definitely this one, not, and definitely not. Simple. Just make sure you read the graph. Just read it, please. Just read. All right, line of best fit. This data does not concern us. Line of best fit, what does that say? The line that best fits the data. All right. So, it's asking us which of these lines best models this data. All right. It's not exactly linear, but we know from Algebra 1 that we can use linear regression to make a linear model that's close to or best fits some data. If we look at C and D, I would hope that you agree with me that these do not best fit the data. All right. In no way, shape, or form model what's going on here. All right. Now it's down to between A and B. Well, A doesn't really include any of the data points except this first one. All right, it's high, so it's estimating on the high end. All right, if we look at B, it's traveling through the midst of most of these points. Definitely the one we want to choose. So please join me in saying, do not choose the ones that are not the best fit. They are not the best fit. Choose the one that is. It goes through most of the points. It's an easy way to remember it. All right, and the last one. Again, we don't have BCRs and ECRs, but I wanted to put this in here to show you because there will be questions on the HSA that require you to make a line of best fit and then choose it from an answer choice. They've kind of reformatted it this year. So I wanted to teach you how to do it. You're going to take this table, all right? It shows the results of an experiment. The first part is to write an equation for the line of best fit. It's just an equation. All right? So, the calculator does this for us. It's not linear. It's not something we can find a constant difference for because there is no constant difference. It will be different every single time. So our calculator will help us do this. We go to Stat and choose number 1, Edit. And I'm going to take my data and type my X values into L1, my Y values into L2, just exactly like I see them. All right, once I'm done with that, I'm going to go Stat. And I'm going to arrow over to this choice Calc. And go to choice number 4, linear regression. And you can always remember that because it's the one that looks like an equation. Look at that. It even helps you out. All right? So, choose that one. And we're going to press enter twice once we get it. And there's our equation. All right? Remember that we have to write it y equals. All right? So, we have a slope and a y-intercept. This is y equals 2.49. Why 49? Because 2 decimal places are plenty. And the next one is a 3, so if it's not 4 or over, then we don't round the next number to the left. Alright, so 2.49x plus 15.15, because that number is 4 or higher, so we round the 4 to a 5. There's our equation. Slope, y-intercept. Remember, the slope is the value of the constant rate of increase. So if this were linear, all right, every time we added a penny, our mass would go up 2.49 grams. And if we didn't have any pennies in the container should weigh about 15 grams. Okay, so that's what this equation tells us. Now, if I wanted to find out how much the mass is with the container when there's 60 pennies, all right, well, I know that pennies is in the X column. So all I would need to do is substitute a value of 60 for X and calculate. I will calculate as soon as I find the calculator. Alright, so I've got 2.49 times 60 plus 15.15, and I get a mass of 164.55. Alright, and I typed it in the calculator just like I saw it, without the y equals.